that
I remember seeing, you showed me pictures of this, and you were actually prototyping this on some breadboard.
That's the thing, because I never know whether to call this breadboard or the...
This is I think this is called Veroboard. Breadboard is the white plastic stuff that you stick the cables in the holes. Yeah. So.
I'm Francis, and me and Howard met a couple of years ago now.
Dancing to somebody playing music, as one does, and found out that Francis is an engineer and loves electronics.
Absolutely loves
component level electronics. And so you've built this for your brother, is that correct?
Yes, it is. Yeah. So it's got a couple of effects in it. It's got a tremolo effect and a ring modulator effect.
Basically, so you've home built this component level, and you've basically put it all on breadboard, all on Veroboard. I think. And there's loads of sort of lovely electronics in there, so we should get into that. But not only that, but it's just a lovely looking wooden box. It's almost like a cigar type.
Well,
that's nicer, isn't it?
I've used cigar boxes to construct these sort of things before, but this one I got at a flea market in Nailsworth, but I don't know what it was before.
Yeah. It looks like it might have been some kind of an instrumentation box, like something that held perhaps a vernier caliper or something like that.
Or compasses,
it could be compasses or drawing equipment, couldn't it? Yeah. But yes, lovely looking piece. So, should we? Yeah, do you want? I was going to say, by all means, let's pull it apart and have a look inside.
Cool. So these are transformers here, these red components, and if you might just about to see there on camera those 4 blue diodes, these little guys down here. So that's the ring modulator. So basically what it is, these 2 transformers, so signal comes in, primary of one of them, and then the secondary, there's 4 diodes. It looks almost like a full bridge rectifier if you see it, but they go all the way around in a circle. That's the ring and the ring modulator.
Okay.
And then connect to the secondary of this transformer. And across those diodes, we connect this local oscillator, which is what these 2 op amps here are generating. And so basically you can think about what they're doing is they forward bias 2 of the diodes and reverse bias the other 2. And then alternately forward bias the other 2, forward bias the 2, swapping back and forth. So you can kind of think about it like is commutating the signal from the secondary of this transformer to the primary of this transformer, and then we hear the output. And the effect of that is this intermodulation. It basically multiplies them together. That's the modulation effect. I mean, for those of you who will have studied A-level maths, you might remember your teachers showing you the formula sine A sine B is equal to 1/2 cosine A minus B plus minus 1/2 cosine A plus B. And you'll know what it's saying is if you have 2 sine waves multiplied together, you will get 2 cosine waves out, with one of them having a frequency that is the sum of the previous 2 frequencies, and the other having a frequency that is the difference between the incoming 2 frequencies. So that is basically what that does. So it's pretty cool. I mean, in principle, you imagine what it should do is you have your guitar going and you imagine like an A note, 440 hertz, with a 1 kilohertz local oscillator is going to give you 660 hertz and 1,440 hertz out. So it should sound like 2 other guitars kind of simultaneously playing with you. So it's an interesting sound. I mean, in this case, because it's not pure sine waves coming out of the local oscillator, it's actually triangle waves. That's what gives it that metallic, almost bell-like sound you will have heard. Yeah.
So that's the ring modulator.
Yeah.
And you've got multiple op amps in here.
Yeah.
So how many op amps in there?
There are 4 in total, but each of these contain 2 op amps.
Yeah.
So there's 8 in total because we have 1 for the actual input amplification. We have 1 that amplifies the output that comes out the primary of this transformer. We have each of the local oscillators takes 2 op amps.
Yeah.
So there's a local oscillator for doing the ring modulator, and then we should probably come on to the tremolo.
Indeed.
Which is really simple, actually, really, really simple. So it is a triangle wave generator that we can control the frequency of, and then the output of that goes into the gate of a MOSFET that literally just
shuts the volume up and
literally
off and
that's
and
it.
on.
Yeah,
excellent.
And so then the depth control on that is literally just a potentiometer between the gate of the MOSFET and the output of the local oscillator. So we're just turning how much we shunt it to ground.
That's the ring modulator there. Then those are the diodes you were talking about. And then we've got 1, 2, 3, 4. We've got 4 op amps across here, and then there's a few discrete transistor MOSFETs and that kind of stuff over there. But yeah, what a wonderful little bit of kit. One thing that we have noticed is it's just a little bit noisy. So the plan at some point is to use some of this metallic tape here to line the inside of the box in order to try and reduce outside interference and that kind of stuff.
You'll see there's no shielding at all between any of the transformers or any of the. You can even fit, when you touch the top, you can get the interference coming right through it. It really is. It does need some. But
yeah, so these are all of the different controls on the top of it. This is an on-off switch and an LED. This is power input here, and then we've got input and output for the guitar and the amplifier. Yes, indeed. So anyway, some really good work that's gone on here, and
some lovely
soldering on the back of it.
It's absolutely horrible.
No, it's great. It's absolutely fine. No. It's all hanging together. It works, doesn't it?
It does work. Soldering is definitely
absolutely fantastic. Really cool work there. There aren't many people that make pedals like this, guitar pedals like this, from analog electronics, from pure analog electronics. Distortion pedals and stuff like that, they're relatively easy to produce. But this is just sort of like another level of complexity that is completely out there. Absolutely, Francis, thank you so much, mate. Thanks very much for bringing it over, and this would be great fun. I hope your brother absolutely loves and adores it.
Well, I will get the other one, which people haven't heard about yet, but I will get that working one day. To have a look at that too.
Yeah, that'll be cool as, absolutely. Okay. Thank you ever so much for watching, folks. Do take care. Have a wonderful week and weekend. Cheers and beers. See you in the next one.
See ya. Bye.